All right, this is problem 8.4.23 and says Alvin paddled for 2 hours with an 8 km/h current to reach a campsite. The return trip against the same current took 10 hours, and we want to find the speed of the boat in still water. So because of the elements in the problem, it's clear that this is a distance equals rate times time problem because it has all of those elements in it. And so the easiest way to do DRT problems is to use a DRT box to organize the information. And then you can pull off a couple of equations from your box. Okay, so we're going to have a box with 3 rows and 4 columns. And these 3 are going to be distance, rate, and time. And then over here we're going to have whatever the 2 things are that we're referring to in the problem. So in this problem we're referring to a trip downstream, and then we have a trip coming back upstream. So I'm going to just write down there for downstream and then up for upstream. Okay, and let's put in the pieces that we know here. So the first thing is, if you're going downstream and you're going to a campsite, so like let's say we're going here, and then you're turning right around and going back, the distance is going to be the same. We don't actually know what that distance is, but since it's going to be the same, we can let both of those be d. Okay. The rates here are unknown to us. Well, so we know one thing. We know that the current has a rate of 8 km/h, and that's true of both going and coming back. But there's actually 2 rates going on in the problem. So there's the speed of the boat, and then there's also the speed of the current. Okay, so what I'm going to do in this problem is I'm actually going to let R be the speed of the boat in still water. And that would basically mean that we're looking at the speed of the boat without the current, without the influence of the current. But the overall rate going downstream will include the rate of the current. So when you're going downstream, you're adding the current to whatever the rate of the boat is. And then when you're going upstream, you'd actually subtract it because it's going to be working against you. And then the time for the 2 trips, it's 2 hours downstream, and it took him 10 hours going back upstream. Okay. All right, so there's our chart for this problem. And once we have the chart, then using this relationship between distance equals rate times time, we can actually pull off 2 equations here. So the first equation is distance is equal to rate times time. I'm going to go ahead and put the 2 in front there. And the second equation that we can pull off is distance is equal to 10 times r minus 8. Okay, and with this now, this is a system of equations. We can solve this however we want. I'm going to use the substitution method for this. So I'm going to go ahead and take that piece and plug it right in there for d. So we're actually going to have 2 times the r plus 8 equal to 10 times the r minus 8. Okay, and now we're just solving for r. So we're going to go ahead and distribute. So we've got 2r plus 16, and over here 10r minus 80. And if we go ahead and get our r's together, so subtract 2r from both sides, I'm going to move the 80 over as well. Okay, so we have 96 is equal to 8r. And then we just want to do a division here, so divide by 8, and we're going to find that r is equal to 12. And this is the rate of the boat, so this is miles per hour. Okay, so that's the speed of the boat in still water for this problem.